Hi everyone, welcome to the course on solid state. So in previous video we have learnt how to calculate the number of particles in simple cubic unit cell, body centered cubic unit cell and face centered cubic unit cell. So in today's video we are going to discuss about how the arrangement of particles will be done in case of solid state. So as you know, while studying the properties of solid state, we have mentioned that the particles in the solid state are closely arranged. So closely arranged means what it indicates, as if I draw the particles like this, okay, this is one kind of arrangement, and I will draw the particles in another row where they are arranged in this manner. Among these two arrangements, this is also one kind of arrangement and this is also one kind of arrangement. When we compare to these two types of arrangements, which type of arrangement is considered as close packed structure or close packing arrangement? Here this one is considered as a close packing arrangement, whereas this type of arrangement is said to be loosely arranged, because here the particles are present in minimum space and maximum particles are present. So when maximum number of particles are present in minimum space, then that kind of arrangement is said to be close packing arrangement. So close packing arrangement, whenever if you want to say which one is or what do you mean by the close packing arrangement, then you have to say the close packing arrangement means when the maximum number of particles occupy minimum space, then such kind of arrangement is said to be close packing arrangement. Now, how the close packing arrangement can be represented in case of solid state, that we are going to study, and this arrangement will be carried out in three stages or three steps. One first step is close packing in one dimension. Close packing in one dimension. This is the first step. And second step is close packing in two dimension. Close packing in two dimensions. Okay, then the third stage is close packing in three dimensions. These are the three steps which are involved in the close packing arrangement of solids. So what we do in close packing in one dimension, how we arrange the particles in two dimension, and then finally three dimension, because you should know first that the crystals having three-dimensional structure, if they are having three-dimensional structure, that means the particles are arranged in three-dimensional space, and hence we have to arrange the particles in three dimension. And in order to represent them in three dimension, first we will arrange those particles in one dimension, then two dimension, and finally three dimension. So what we will do in a one dimensional arrangement, two dimensional arrangement, three dimensional arrangement, that we will learn. Before that, if I say the particles are closely arranged in this manner in a particular kind of crystal, okay, now here you should know the term known as coordination number. So one term meaning you should know, that is coordination number. Then what does this coordination number means? Coordination number means it is the number of nearest neighboring atoms surrounded to each constituent particle. What does this means? It simply indicates, now I will consider this particle, okay. Here, how many particles are surrounded to this constituent particle? Means, how many particles are attached to this constituent particle? This is one center particle. Now, how many atoms are attached? If you closely look at this, then this is one particle which is attached to this constituent particle. This is another particle. This one is also attached, and this one is also attached to this central constituent particle. So totally, how many atoms are closely or attached to this or surrounded to this constituent particle? There are totally 1, 2, 3, 4. 4 constituent particles are surrounded to this constituent particle, and that number is said to be coordination number. In this case, the coordination number is 4. What does this coordination number indicates? Number of nearest neighboring atoms surrounded to each constituent particle. Okay, if I consider this type of arrangement, okay. Now, if I consider this constituent particle, what is the coordination number here? If you look at this atom is surrounded by how many atoms? Nearest neighboring atoms. This one, 1, and this is another one, 2. So, the coordination number is 2. Okay. So, this is how we should know the term coordination number, which indicates the number of nearest neighboring atoms surrounded to each constituent particle. Okay. Remember this term. It will be helpful while learning or while studying the close packing in 1 dimension, 2 dimension and 3 dimension. So, now we will look at how close packing arrangement will takes place in 1 dimension. In close packing arrangement of 1 dimension, first you should know 1 dimension term meaning. 1 dimension means we can move any object at one axis only, along one axis, or in only one path it can move. 2 dimension means it can move in 2 directions or 2 different paths. 3 dimension means it can move in 3 different paths or in 3 different directions. For example, if I consider 1 dimension, I will consider this one as x-axis. Okay. So, if I consider this one as x-axis, then 1 dimension means the particles will move along this x-axis only. It does not move in any other directions. And if I say the particle can move along x-axis as well as along y-axis, then it would be 2 dimension. Okay. And if I say the particle can move in 3 different paths, okay, then it is said to be 3 dimension. So, you should know the meaning of dimension, okay, that you have already learnt. If a particle move in only one axis, then it is said to be 1 dimension. If the particle can move in 2 axes or 2 paths, then it is said to be 2 dimension. If the particle is able to move in 3 directions or in 3 axes, then it is said to be 3 dimensional structure. Okay. Now, first of all, you should know that we all are present in 3 dimensional space. Okay. means whatever the objects you will see, almost all objects are three-dimensional because we are living in three-dimensional world. Okay. Now, here first we look at one dimension. So, one dimension means the particles can move only along x-axis. Okay. In this manner, we can represent the arrangement of particles. Okay. A number of particles. You may join infinite number of particles. Okay. So, this is one dimensional arrangement. When the particles are attached with each other and plotted in one dimension, then such type of arrangement is said to be close packing in one dimension. Now, here what is the coordination number? Close packing arrangement in one dimension. What is the coordination number in this kind of arrangement? So, observe, if I consider this particle, how many nearest neighboring atoms are there? This one, 1 and 2. Is there any? Here also empty space is there, here also empty space is there. So, there is only 2 neighboring particles are surrounded to each constituent particle. If I consider this particle, here also the coordination number is 2. If I consider this particle, what would be the coordination number? It is surrounded by this one atom. Okay. And is there any atom here? Yes. Here also the atoms are present. While explaining these concepts, you should consider the number of particles present will be infinite. Okay. Means if I have stopped here, it doesn't mean there is no atom or particles after this. There may be or should be presence of the particles, but due to lack of space we won't represent them. Or if I ask what is the coordination number of this particle, then you should not say that its coordination number is 1. Its coordination number will be 2 because there is a arrangement of infinite number of particles will be observed. Okay. So, this is about close packing arrangement in one dimension. Then second type of arrangement is close packing arrangement in two dimension. So, as I have told you, now if I consider this one as x-axis, this is one dimensional arrangement because particles can move in this direction only. Now, if I place the another particle or another row of particles in this manner, okay, then it is said to be close packing arrangement in two dimension because now it is moving along y-axis as well as along x-axis. So, this is how we can represent the close packing arrangement in two dimension. Now, if I say it is a two dimensional arrangement, now what would be the coordination number? If I consider this particle, okay, now this constituent particle is surrounded by how many neighboring atoms? 1, okay, this is attached to this. This atom is attached to this atom and this is also attached and this is also here it is attached, okay, 4. So, totally 4 neighboring atoms are surrounded to this constituent particle. Then the coordination number will be how much? Coordination number is 4 because each constituent particle is surrounded by 4 nearest neighboring atoms. If I consider any atom, then its coordination number is taken as 4. And now, if I join the centers of these spheres, what I will get? I will get this square. Okay, square is formed upon joining these centers, and hence this type of arrangement is said to be square close packing. Okay, square close packing, that is SCP. We will call it as SCP, square close packing, because it forms square when we join the nearest centers of nearest neighboring atoms, and its coordination number is 4. Now another thing, if I consider this row and I will give the name A for this row, what name can I give to this second row? Simply here, is it the second row, is it the same as first row? It is same as first row, because the second row particles are exactly kept on the particles of first row, and hence, okay, it is also named as A only, because both are same, both are having same number of particles, same kind of arrangement. And if I say third row, what I can say to the third row? Is it same? It is same as first row as well as second row, and hence I will name it as A only. If I consider fourth row, that fourth row is also same, and hence it is also named as A. So if I keep on placing these number of particles on one another, then all the arrangement are said to be AAA type arrangement. Okay, this kind of arrangement is said to be AAA type of arrangement. Okay, where you observe this type of arrangement in square close packing. How many dimensions? 2 dimension. 2-dimensional square close packing. Here the coordination number is 4 and the type of arrangement is AAA type of arrangement. Okay, and there is another possibility of arranging the 2-dimensional close packing. What is that way? Again I will consider the 2-dimensional axis. Now I will place the constituent particles. Okay, now in this I have kept the second row particles exactly on the first row particles, but now I will place the second row particles at the depressions of first row particle. I will not place on this particle, I will place at this depression. So this is also considered as close packing arrangement in 2 dimension. Okay, so here you will get this kind of arrangement. Now again I will place so in this manner we will arrange the particles in 2-dimensional. Now if I consider this as a central particle, you can consider any particle, so I am considering this particle. Now how many particles are surrounded to this particle? Means simply see how many particles are attached to this particle. This is attached 1, 2, 3, 4, 5, 6. So 6 particles are surrounded to this constituent particle, and hence the coordination number is 6. Okay, for 2-dimensional close packing arrangement, here the coordination number is 6. And if I join the centers of these neighboring atoms, what I will get? I will get the hexagon, and hence that type of close packing arrangement is said to be hexagonal close packing arrangement. How many dimensions? 2 dimension. 2-dimensional hexagonal close packing arrangement. And if I consider the first row as A, I will name it as A. Then second row, will it be same as first row? See here, in this case, both are similar to each other or same to each other. But here, they are not same because the particles are not kept exactly on the first row particles, and hence this second row is said to be B because this is different from the first row. Observe the third and first row. The third row particles are same as first row particle. See here, they are exactly on one another. Okay, and hence the third row is said to be A. Then fourth row. It is similar to which row? Second row. It is similar to second row, and hence this is named as B. So this will continues up to number infinite particles. So this kind of arrangement obtained is said to be AB type of arrangement. Okay, this type of arrangement which is obtained in hexagonal close packing. How many dimensions? You have to remember 2-dimensional. 2-dimensional hexagonal close packing. The type of arrangement is AB type of arrangement and coordination number is 6. Okay, this is hexagonal close packing and this one is square close packing. The important thing that you have to remember here is coordination number, type of arrangement. Which type of arrangement is observed in case of square close packing? Then you should say coordination number 4 and type of arrangement is AA type of arrangement. And which type of arrangement is observed in hexagonal close packing? Then you should say AB type of arrangement. What is the coordination number? Coordination number is 6. So this is how we arrange the particles in 2 dimension. This is all about close packing arrangement in 2 dimensions.